Alright, here is a video on division and negative exponents because they're related. The other video covered multiplication, exponent to a power, and exponent of 0. You can see that in the first video. This is part 2 of laws of exponents. It helps you to simplify, and I'll do a video about simplifying exponents. But this one right here, we're going to go over first division. So when you have a problem like x to the 4 over x to the 2. This says that we can subtract 2 from 4, and it should equal x over 2. If you see here, that's what this says. M subtracted by n. Let's see how that works, though. On the top, oops, that should be an x. On the top, we have 4 x's multiplied by each other. So each of these has a multiplication symbol between them. On the bottom, we have 2 x's multiplied by each other. And that means that we can cancel out 2 x's because there's 2 x's on the bottom, 2 x's on top. It is a fraction, which means we're dividing. So 4 x's, we can take 2 x's out of that, and we're left with just x times x, or x squared. So let's do a slightly more complex one, if that makes sense. So just remember when you've got an exponent on the top and an exponent on the bottom, you subtract the bottom from the top, and it makes a full exponent for you. Let's do a more complicated one. So in this one, we're going to be discussing. So let's do the one they've got. Let's pick one example here. Let me see if I can find one. Oh, that's a good one. Yeah, let's do that one. Let's do number 7. It says 3z to the 5th over 12z to the 3rd. Okay, so first off, let's write it out like this. So that's 3 with 5 z's. And each of these has a multiplication symbol between, but there's no need to write it, so I'm going to just write it like this. This one is 12 with 3 z's. So now we know we can look at this. So 3 doesn't divide by 12 nice, but 12 divides by 3. We get 1 over 4 so far. Now we need to decide what happens with the z. Because 3 times 4 is 12, so if we put it like that, that's reducing a fraction. So we've reduced that part of the fraction. Now we say we've got 5 z's on top, 3 z's on bottom. So we're going to go 1, 2, 3, 1, 2, 3. We're left with 2 z's on top. So our final fraction, z squared over 4. If we're going to look at the top here, let's do it without writing it out. 5 minus 3 is 2, so we know we're going to have z 2, and that matches that. We know for sure that z2 is going to be on top because 5 minus 3 equals that. 12 divided by 3 equals 4. Since 12 was bigger on the bottom, the 4 goes on the bottom. Again, I'll repeat that. 12 divided by 3 is 4. Since 12 was bigger on the bottom, we put the 4 on the bottom. We reduced the fraction. But now you've got z squared divided by 4, as the answer, and that's what we got when we wrote out the other stuff. But division also helps us, so that's division of exponents. Division also helps us describe another portion. It helps us describe, we're going to do, oops. Okay, it helps us to describe negative exponents. So say we had this. We had x to the third over x to the 5. Now, if you remember, when we had x to the 5 over x to the third, it equaled x to the 2. But what happens here? Let's see. 1, 2, 3. So 3x is on top, 5x is on bottom. Now, we know that the way we did it before is we crossed out 3x's on top and 3x's on bottom, but we're left with no x's on top, so that equals 1 on top, and with 2x's on bottom. That's kind of weird. That's what we're left with. We're left with 1 over x squared, right? It's weird. But there's another way to write this. Say we take this. We take x minus 3, or x to the third, minus 5. That gives us x to the negative 2. Well, how do we get rid of a negative? Like this. We get rid of a negative by turning it upside down. So a negative exponent becomes a positive by putting it on the bottom, just like we have here. So anytime you have a negative exponent, say this, say x to the third, or x to the negative 5, that will always equal 1 over x to the 5th. So this is the basic laws of exponents part 2. I would encourage you to read over that, watch over that, and watch for another video coming about how to do longer exponents and stuff like that. All right, thanks.